Imagine a bridge so vast, so daring in its vision, that it doesn't just cross the sea, it dives beneath it, emerges through man-made islands, and soars again across open water. Hello, welcome again to Civil Engineering Edge. In this video, you will see a masterpiece of a tunnel, a bridge. This isn't science fiction. This is reality, sculpted from steel, concrete, and human ambition. This is the Shenzhen-Zhongshan Link, a jaw-dropping, about $7 billion engineering marvel, built by China to connect two booming megacities, transform travel, and reshape the future of an entire economic region. Stretching nearly 50 kilometers in total, this mega project is far more than just a bridge or a tunnel. It's a seamless fusion of three colossal structures: a 6.8 kilometers undersea tunnel, carefully laid beneath the seabed, over 17 kilometers of gracefully arched sea bridges, and two massive artificial islands anchoring the transition between land and water. And all of it comes together to slash travel time between Shenzhen and Zhongshan, from a grueling 2-hour inland commute to a breezy 30-minute high-speed journey. Before this link, crossing the Pearl River Delta was a daily test of patience. The inland route twisted around rivers, city congestion, and endless toll stops. Now, motorists cruise at 100 kilometers per hour across 8 pristine lanes, spanning bridges that seem to float above the sea, and dive through tunnels that defy ocean pressure and geology. But this iconic structure was born not from convenience, but from exclusion. In the early 2000s, when Hong Kong-Zhuhai-Macau Bridge was announced, Shenzhen, one of China's fastest-growing tech and business hubs, was left out of the plan. The message was clear: you're not part of this connection. But Shenzhen wasn't going to be sidelined. By 2008, leaders proposed a new, independent link, one that would not only include Shenzhen, but redefine the entire Pearl River Delta. And by 2011, it was officially folded into China's ambitious Greater Bay Area Development Plan, a blueprint to unite multiple major cities into a single, hyper-connected powerhouse economy. Construction began in 2016, with challenges that would test even the most seasoned engineers. Building massive bridges in typhoon-prone waters, excavating an undersea tunnel 6.8 kilometers long, threading it beneath shipping lanes, and constructing artificial islands from the seabed up, all while keeping the environment in check. By 2018, bridge spans were rising against the skyline. By 2022, they were sealed. And in 2023, the last segment of the tunnel clicked into place like a perfectly aligned puzzle piece. The full corridor opened on June 30th, 2024, and the impact was immediate. Over 100,000 vehicles per day surged across it in the first weeks alone. For commuters, it was a dream come true. For engineers, a badge of honor. For the world, a glimpse of what next-generation infrastructure looks like. At the center of it all stands a record-breaking Shenzhen-Zhongshan Bridge, a breathtaking suspension span with a main stretch of 1,666 meters, high enough to let the world's largest cargo ships glide beneath without pause. Its towers soar like sentinels above the waves, holding up lanes of traffic with cables as thick as tree trunks. And on the western side, the Zhongshan Bridge, a 580-meter cable-stayed marvel, crowned by 213-meter-high towers that rival city skyscrapers in height and elegance. A tunnel beneath the sea, a feat beyond imagination. Now imagine this: a tunnel deep beneath the surface of the sea, made from 32 colossal concrete and steel segments, each over 100 meters long, each weighing nearly 80,000 tons. That's the weight of a fully loaded aircraft carrier. This isn't just any tunnel. This is the world's first 8-lane immersed tunnel, and at 46 meters wide, it's also the widest undersea tunnel ever built, a marvel beneath the waves, and a bold step into the future of global infrastructure. Built at a cost of $4.8 billion, this undersea passage was designed to handle the pressure, literally and figuratively. Its goal? To smoothly carry over 100,000 vehicles every single day without a single traffic light, toll booth, or speed bump in sight. Gone are the old toll plazas, replaced by a fully electronic tolling system. Cars are charged automatically, 66 units per vehicle, no human interaction needed. But the real genius of this tunnel lies in what you can't see. This structure isn't just smart, it's intelligent. Hundreds of sensors embedded throughout the tunnel constantly collect data: air quality, traffic flow, structural integrity, and more. A central AI-powered control hub interprets that data in real time, predicting traffic patterns before they happen. Autonomous robots patrol the tunnel, scanning for anomalies, The lighting system adjusts dynamically, adapting to vehicle speed and density. Even GPS signals, which typically vanish underwater, have been engineered to work seamlessly within the tunnel, a world-first achievement. Let's rewind to the beginning, to where the tunnel starts. Building an immersed tunnel of this scale required more than just digging. It demanded the creation of entire man-made islands from the seabed up, and that's where we meet the West Artificial Island, a spectacular feat constructed in just 141 days. How? Using 57 giant steel casings, driven into the ocean floor by the world's largest synchronized vibration hammers, working in perfect harmony like a mechanical orchestra. The result? A massive 100,000 square meter diamond-shaped platform, engineered to withstand ocean currents and heavy-duty construction, and stable enough to serve as a launch pad for the tunnel beneath. But on the east side, engineers went even further. They didn't just build an island. They created the world's first underwater highway interchange. Yes, a submerged road junction where vehicles can merge, exit, or switch directions, all beneath the sea. Constructed with millimeter-level precision, this engineering marvel is unlike anything else on Earth. To make this tunnel a reality, engineers had to invent an entirely new supply chain. Robotic casting systems were developed to ensure every segment was perfectly shaped. Rail-mounted transport cranes hauled the segments to sea with pinpoint accuracy, and new techniques reduced seabed dredging, preserving marine ecosystems while lowering costs. This wasn't just a tunnel. It was a revolution in construction. Above the waves, the Shenzhen-Zhongshan Bridge towers like a colossus. Its 1,666-meter main span is held aloft by cables that soar 91 meters above the sea, tall enough for the largest ships in the world to pass beneath without slowing down. Naturally, comparisons have been drawn to its iconic neighbor, the Hong Kong-Zhuhai-Macau Bridge. Yes, that bridge is longer, 55 kilometers in total, but the Shenzhen-Zhongshan Link, it represents a new generation of infrastructure. 8 lanes, not 6. A single domestic expressway with no border crossings or permit checks. A streamlined design that prioritizes speed, simplicity, and sheer engineering elegance. And the numbers speak for themselves. In just 4 months, the link has seen over 10 million vehicles surge across its span. From deep-sea foundations to skyscraping towers, from robotic construction to AI traffic control, the Shenzhen-Zhongshan Link didn't just break records. It rewrote the playbook. A tunnel, a bridge, 2 artificial islands, 1 unshakable vision. This isn't just infrastructure. It's a glimpse into the future of transportation, bold, seamless, and unstoppable. Breaking limits, reimagining possibilities. Both the Shenzhen-Zhongshan Link and the Hong Kong-Zhuhai-Macau Bridge are titans of modern engineering. Both span vast waters, connect major cities, and rely on an intricate blend of tunnels, bridges, and artificial islands. But here's where the Shenzhen-Zhongshan Link breaks away from convention and charts its own course. While its famous neighbor runs a tunnel in the middle, the Shenzhen-Zhongshan Link strategically places its tunnel on the eastern end, a brilliant move that avoids busy international shipping lanes and keeps clear of airport flight paths. And tucked beneath the sea, it unveils something the world has never seen before. The first ever underwater highway interchange, a submerged junction that lets vehicles switch seamlessly between the tunnel and expressways all below sea level. A true engineering marvel, unmatched by the Hong Kong-Zhuhai-Macau Bridge. When it comes to pushing boundaries, the Shenzhen-Zhongshan Link doesn't just keep up, it raises the bar. Its 1,666-meter suspension bridge span isn't just longer, it dwarfs any similar structure on the older link. And while the Hong Kong-Zhuhai-Macau Bridge took 9 years to complete, the Shenzhen-Zhongshan Link was built in just 7, thanks to cutting-edge digital systems, real-time construction monitoring, and next-generation technologies that accelerated progress while ensuring precision. Few projects on Earth can rival this one in complexity and innovation. The Hojo Bay Bridge may stretch longer, but it's a straightforward structure. The Nanchang Bridge may span greater distances, but lacks immersed tunnels and artificial islands. Even the famed Chesapeake Bay Bridge and the Øresund link between Denmark and Sweden are impressive, but smaller and simpler by comparison. And beneath the surface of these record-breaking numbers lies a story of resilience and precision. The South China Sea is not a calm place. Engineers had to tame a soft seabed, brace against typhoon winds, and ensure rock-solid stability for decades to come. They developed innovative deep foundation methods, plunging massive supports deep into the Earth's crust. Every detail was crafted for endurance. The West Artificial Island wasn't just an aesthetic choice. Its unique kite-shaped design helps redirect ocean currents, allowing water to flow naturally around it. This shape reduces tidal disruption, prevents erosion, and protects marine life. But perhaps the most admirable aspect? A commitment to environmental responsibility on a massive scale. Piles were installed with vibration control technology to protect the endangered Chinese white dolphin. Bridge piers were aligned with the direction of tidal flow to aid fish migration. Dredging was minimized to preserve delicate seabed ecosystems. This wasn't just a battle against nature. It was a partnership with it. Safety wasn't an afterthought. It was built into every inch. Emergency cross passages let drivers escape safely between tunnel tubes. A hidden service gallery runs above the road, ready for rescue teams and maintenance crews. Gradual lighting transitions at tunnel entrances prevent the black hole effect that disorients drivers. Even the bridge deck is subtly curved to match Earth's curvature, helping with rainwater drainage and long-term structural balance. And then, one last surprise. At the East Artificial Island lies China's first ever underwater transfer junction. Drivers can shift lanes, merge, or transition from local expressways to the undersea tunnel without ever surfacing. A seamless underwater interchange, engineered with millimeter-level precision and executed on a scale never seen before. The Shenzhen-Zhongshan link is more than a bridge, more than a tunnel. It's a living symbol of what's possible when vision meets technology, and humanity dares to build beyond limits. If this project amazed you as much as it did us, hit that like button and subscribe for more deep dives into the world's most ambitious engineering marvels. Got a question? Want to share your thoughts? Drop them in the comments. We read every single one. Thanks for watching, and we'll see you on the next build that dares to defy gravity, geography, and expectations. Please don't forget to like, comment, share, and subscribe to Civil Engineering Edge. Stay till next video, please.